All right, let's look at a little application here. So graphs of two equations. Here are two graphs that represent situations you have seen in earlier activities. The first graph represents A equals 450 minus 20t, which describes the relationship between gallons of water in a tank and the time in minutes. So A stands for amount and T stands for time. Where on the graph can we see the 450? So if this is our equation up here, where is that 450? Now notice that 450 is right there on our graph. So that's the amount in the tank right there. So 450 is the, and what we call that? We call that the y-intercept value. All right, so in other words, the coordinates, the ordered pair coordinates at that point would be 0, 450. Where do we see the negative 20? All right, well, the 450 is pretty obvious, at least I think it's obvious. We can kind of see it there, but the negative 20 right here, that negative 20 isn't as obvious. We do know that it is the rate of change or the slope of our graph because we see that linear equation and we can see that number is in front of that variable, which is the spot where the slope usually is. All right, so let's just say this. We can't really, quote unquote, see the negative 20. However, we know it has something to do with the slope. So before we write anymore, let's just see if we can identify the slope. Now, if we can look along this line and look to see where the line crosses the corner grid square, where we can see exactly what that is. Like this point right here is 10, 250. Let's keep following down until we see another spot where it crosses right in the corner, right? Like maybe right there. Okay, so we have a couple points, which means we can do a little bit of a slope triangle between these. You can do that triangle above the line or below the line, but you either go over and down or down and then over. So we went down and then over. So in this case, since we went down, the question is how much did we go down? Notice that the scale over here is going by 50s. So we actually went between 250 and 50. So that was what we call a rise, but not really a rise because it's going down, but think of it as a negative rise. We went down 200, and then we went from 10 all the way up to 20, so that would be a run of 10, right? So as a rise over run, that is negative 200 over 10, which is negative 20, which is the number that we saw in the equation. Okay, so how do we see it? Well, after we calculate the slope, we can see that that is the slope. So let's just say that. However, when we find 2 points on the line and calculate the slope between them, the rise over run between them, the slope between them, we see the slope is negative 20. All right, so now let's attach meaning to our 450 and our negative 20. So back up in our problem, what did the 450 mean? Okay, so let's think about that 450. We're talking about time on our x-axis. We're talking about amount of water in the tank on the y-axis. So when we're talking about that 450, we're talking about 0 on the time and 450 on the amount of water. All right, so at 0 minutes, there is 450 gallons of water. At 0 minutes, there is, or maybe there are 450 gallons of water. In other words, the tank starts with 450 gallons. Sometimes we think of the y-intercept as the starting point. Now on a line goes on forever, both left and up and down and to the right, but the realistic interpretation of this line, we only really can have time that's in a positive number of minutes and amount of water that is in a positive or zero amount. We can't really have negative time and negative amounts of water. So in the case of this, it really is kind of like our starting amount of water. Okay, and then the other piece is, what is that negative 20 mean? That slope, what does that mean? Well, we talked about back on the previous page that the slope tells us for every one x value how much the y value is increasing or decreasing. So let's think of every one x value, so that would be minutes. So for every 1 minute, it tells us that the amount of water in this case is decreasing, so our line is going down, by 20 gallons. All right? For every 1 minute, the gallons of water are decreasing by 20. All right, so, or maybe a better way of saying that, for every 1 minute, the water is decreasing by 20 gallons per minute. So I'm going to actually add that on here. If I had to rewrite that, I might write that sentence just a slightly differently, but I'm going to stick with it. In other words, the water is being drained at 20 gallons per minute. All right, so that's the meaning, and that's the big thing we want you to be able to do, is write the equation or look at an equation, but also in the context of a problem, tell us what the numbers mean, because they have very specific meanings. So I want you to be thinking